Hi everyone, my name's Alex King. I run DevOps at Gogo. And before we start, I wonder if you could do me a favor. So the Sibin is here from the DevOps team, but the rest of the DevOps team is in Chicago and they're live streaming. So I wonder if everyone here could say on three, hello DevOps, just to say hello to those guys. Is that okay? All right. 1, 2, 3. Great, thank you. So the reason why I say that is I'm privileged to be here to do this presentation, but it's really all those guys in Sibin who are the real heroes that have done all this work. A little bit about us first of all. So Gogo, lots of statistics, not going to bore you with those. We were we have been and we are leaders in running Wi-Fi on airplanes, which two of my favorite things are Wi-Fi and airplanes. So I think that's pretty cool. In Belgrade, we work with a company called Interventure, and they host our office here. And Interventure is a pretty cool company. And if you are interested in doing Java development, then come and talk to us at Interventure. I think this is probably the last interactive thing I've got for you guys. So first of all, if you're, who here has worked for a small company, put your hand up. Okay. So now, who here has worked for a big company, put your hand up. All right, so last one, because I'm not really good with Venn diagrams. If you work for a big company and a small company, put your hand up. All right, so quite a few of you, good. So the reason why I say that is we go from having a small company to working at a large company, and the culture and the way things work are actually pretty different between the two. And the reason why small companies tend to go faster than large companies is because of the changes that happen through an organization's lifetime. So a couple of guys to get together, they have a few beers, they get an idea, they start a company, and things come along, and they're actually working out pretty well. They've got their first product coming out, they find a customer, and then over time, things develop and move on, and as they go, then the velocity drops, and they get bigger and bigger and bigger, and then things like technical debt start coming in, and the velocity drops. And so the difference between those two is when you're a startup, there's probably the CEO maybe, and the guy who writes the code. Sometimes the guy who writes the code is the CEO. Sometimes the guy who's the sysadmin is also the CEO. You just don't know. So either way, it's really, really small. When you get to a large company, what happens is you get these sort of silos developing, because in a production line sense, we think that production lines are very efficient. So we end up with someone who writes the code, someone who deploys the code to test, someone who tests, and you can read the rest. So there's a whole bunch of different roles and different people that go from having writing the code in the first place through to someone who pages people when stuff goes wrong in the middle of the night. But it's even worse than that, because aside from those people, there are also other people, even aside from things like HR and finance, but there are people who run the network, people who do project management, people, maybe you have a separate database team. And I love this little guy down here who audits stuff. When you're in a large company, I put this next slide together because I think it's also quite fun. A card called Dysfunctional Bingo. So who here recognizes any of these boxes? Okay, yeah, quite a few of you, right? So what would be fun, I think, we won't do it right now, but what would be fun is if somehow or other we could kind of put post-its in each one of these and see how they stack up in terms of popularity or dispopularity, or whatever the word is, there's the opposite of popularity. But does anyone want me to talk about any particular ones of these? Okay. Well, we'll get to a couple in a little bit, so you'll see. Like yak shaving. Yak shaving is one of those things I learned about 18 months ago when I was starting to get into DevOps. And it's a really crazy sounding thing, but the idea is you want to get this one simple thing done, and it should be straightforward. You should be able to go and do that thing. But it turns out that you've got so much wrapped up process that you have to do this. To do this one thing, you have to do these 5 other things first. And so one of the big things about DevOps is eliminating all that unnecessary stuff. So here we are. You're a big company. You want to have that old velocity that you used to have when you're a small company. And so you want to do DevOps, but you don't really know what it means. So you might have an idea what it means. I think pretty much every company has to figure out for themselves what really DevOps means to them. So what I'd like to do here is talk about our journey. So that's kind of where the intro goes. So again, you're working for a big company. You're looking back to how it used to be. And rather than having things just work the way they should do, maybe not as fast as you like, or maybe you don't have any money in the bank because you're a startup, but it really shouldn't have to be like this. And every time you do a deploy, you should be relatively comfortable that you know exactly what's going to go on. It's going to be predictable. You can move a small amount of traffic over, and it's safe. Not that it'll always be that way, but most of the time it should be that way. So you remember that swirly chart, the pipeline of steps. It shouldn't be like that. It should be back where you've got a small amount of code, you manage it from end to end, and it should be clean, it should be predictable. So Robert actually showed this slide yesterday, and one of the things I liked about his slide was it was a little bit different. So he had some of these bubbles facing out towards the different applications that we use. And so for the most part, you don't want the developer to do mundane stuff. You want the tooling to do the mundane stuff and have the developer spend their time doing the clever stuff that they're getting paid lots of money for. Hopefully getting paid lots of money for. If you don't get paid lots of money, you should come and talk to us. So one of the things that we use to make us go faster is a tool called Spinnaker. It started out in Netflix a couple of years ago and just became open source at the end of last year, beginning of this year. And one of the great things about Spinnaker, and if you can see this bar below that, below the green bar there, but you can define a pipeline of stages very, very easily. So in some ways, it does similar things to Jenkins, but it's a much more integrated, structured, clean way of doing orchestrating, build, and deploy. So what we've got in here for our pipeline is we basically create some immutable infrastructure, which is one of those really, really important things that I'm not going to talk about very much. But we build it, and then we can deploy it to different environments. We can run automated testing, and we don't have a QA organization anymore. We have a QE, or quality engineering organization, and their job is to automate as much testing as possible. And automating testing is incredibly important because at the end of the day, you don't have your people spending a lot of time doing manual tests when you're trying to accelerate your deployment velocity to production, because it's going to kill you. So yeah, so that's one of our pipelines. And so next slide. I hate having slides with lots of bullets on because I can't read it faster than you guys can. So, but this one slide, I just had so much information on it that I felt like I needed to just put a wall of text in front of you. So sorry for this. But there were a whole bunch of things that we figured out along the way, and the first thing you have to do is recognize that change across an organization is hard, and that it's going to take a long time for you to actually change the culture of an organization. But you've got to start somewhere, right? So you've got to have the right ideas. You've got to figure out what the right things to talk about, the right dialogue to have first of all, how you can start being successful and building for the future. One of the things I used to think maybe a year, two years ago when I was working at my last company was I didn't really feel very empowered. My boss didn't really get the idea of DevOps, and because my boss didn't get the idea of DevOps, I thought, well, maybe it's not really going to fly, and I self-doubted myself. Well, I don't know how you would self-doubt someone else, but yeah, I self-doubted myself. And when I came to Gogo, I was very fortunate enough to come work for a guy that really did understand DevOps and really did get it. So That was remarkable. But now I'm on the other side of the fence and I've done DevOps. I think it might be a little bit different. It might be that it was only my own perceptions that were holding me back. And if you've got the right ideas, the right enthusiasm, a little bit of charisma maybe, but you can take people with you, then that's good enough. Don't wait for your boss to say it's okay, because your boss may never say it's okay. I had a really interesting talk I listened to the other day, and we're talking about communication, and communication isn't just sending people emails. It's going and personally asking them what they think. It's showing them demos, asking for their advice, getting feedback, and just working on it. And also, people have a belief system, right? They believe that one thing is the way they're doing things is probably the way it should be. And there was one person who said, not so long ago, it's worked this way for the last 9 years, why would we change it now? Which is not very DevOps. So we want to figure out how to bring people with us, and there are some ideas here that hopefully, if you haven't really got very far in your DevOps journey, then some of these things might be useful. So I'm going to talk about change management very briefly, because change management is a really important part of how you do DevOps. And as you're trying to accelerate your deployments, then change control can either really slow you down or speed you up. So for me, the kind of traditional way of thinking about change control is how do we make sure that changes don't damage the business? And that's okay, but you can either do that through control and real control, and you can have people signing off on changes, or you can say, what can we do to automate our tools? What can we do to ensure that safe, effective change happens, but potentially automatically, or in a least intrusive way as possible? So I've talked really a lot about people, and I've talked about philosophy, and I've talked about the ideas to get you there, and I haven't really talked about technology yet. So I'm going to spend a couple of minutes talking about technology and some of the tooling that we used along the way. We started roughly last July or thereabouts, and the first thing, just a couple of us on the team then, the first thing we did was we were just so overwhelmed with all these things that are ahead of us, but we couldn't really, if we just were overwhelmed all the time, obviously we wouldn't get very far. So we took a look at some of the big things we needed to do first to make an impact, and we were using a hosted GitHub, and it was kind of okay, I guess, but everyone had their own private logins, and we weren't really sure whether there were maybe any former employees that still had access, and that obviously is not very cool. And it's a flat namespace, so we had 350 repos, and we weren't really sure whether they were all being used or not, who owned them. It was very, very messy. So we spent quite a bit of time talking to development teams and making sure we got them comfortable with moving, as it happens, to GetLab, but it doesn't really have to be GetLab. But we wanted a safe, secure system, which was highly available, although we did actually have an outage yesterday. But generally speaking, last year has been fantastic. And come up with something that is there for our developers, but also is actually manageable. And then with these other dozen or so tools, we were at the point where we can go from a piece of source code to having a piece of immutable infrastructure. So immutable infrastructure is really important because it means that your base OS and any frameworks that you use and the application code that you created is going to be exactly the same whether you're deploying it in a development environment, potentially on your laptop if you were using laptops, this kind of thing, or production. And because it's the same everywhere, it means that you'll never, doesn't matter how many servers you deploy, if you deploy one server or 20 of them, they all have exactly the same image on them. So you never have to worry about this thing where perhaps you forgot to patch one of the servers, or you updated the configuration on one server incorrectly, or however it goes. It's just all exactly the same. So then that's Q3, our third quarter of the year. So fourth quarter leading up to the end of 2015, we're actually getting to the point where we're deploying applications through this pipeline into AWS, into different environments. We had maybe half a dozen or so applications from these developers that didn't really, 6 months ago, they're going, what is this? I don't really understand. And we had a couple of people that were really, really enthusiastic, got the idea, and just embraced it and ran with it. And it was just so awesome to see. And that means things like auto-scaling groups, load balancers, all these things here. You can read it just as fast as I can. So then we're going into the beginning of this calendar year, and we're starting to add in a bunch of other systems and tools like VictorOps. So VictorOps is great because we can attach, we can take our metrics that are running against the applications, set alarms and thresholds, and hosted Graphite or what have you, and then feed those into VictorOps. So now that if teams start to see problems with their application running in production, we can set it up so that someone on call gets paged. So this means now you've got a developer who's writing code, and when their code's working great, it's working great, but also when the developer has some problem, the developer actually gets very fast feedback when there's a problem with code. And the great thing about that is, rather than having an operations team that's just sort of really, really stressed in the middle of the night because they don't really understand what's going on, and they spend half their time rebooting servers because that's really all they can do, because they can't redo the code. So this means that the whole thing is a lot faster. We've got a much tighter feedback loop, and tighter feedback loops are good. So then end of Q2, which is up until June of this year, we're actually starting to think about things like Sarbanes-Oxley, which is an important thing, particularly in the US, for making sure that companies behave themselves and don't report incorrect financial data and credit card applications or applications that consume credit card information. So now we're getting pretty serious about this. Now Amazon's good with their certifications, but there's a lot of stuff that Amazon can't do, and a lot of it's about how you figure out how you want to aggregate and segregate the different environments and applications and how they communicate. And so for me, that was great because I like paying my mortgage. So probably the biggest thing this quarter just finished, which was actually the end of this week, is we did two really, really major things. One, so Lambda functions, so if you know about Lambda functions in AWS, but the idea is you can actually deploy a piece of software without any servers. So when you have an API event or message come in, it gets processed for you, you get a result back, it's good. So we don't have to worry about EC2 instances, and it's very easy to plug into other systems like storage systems or databases or message queues or what have you. And the other one, and I'm still super, super stoked about it, and we'll talk about it a little bit more later, but Foremast is a piece of open source that we created in support of Spinnaker. We'll talk about that more in a minute. So through all those things, that's great, it all works. We've actually sort of exploded with our use of GetLab. So we had 350 repos roughly in the old system, and we went and reduced we took about 100 or so out just because they weren't really ever used. And then since, where's that, March? Yeah, beginning of March, we've gone from 400 repos to over 1,000. And that just blows my mind. And probably there's some of those we can do some cleanup for, but the thing about this is it shows you the rate of innovation, the rate that we've been able to create new pieces of software. And probably just as importantly, we added a extension into our tooling a couple months ago, which started reporting how many deployments we're actually doing. So the orange line is how many deployments we're doing through Spinnaker, and the blue line is how many deployments we're doing in the data center. And so you can see now we're almost double the volume of deployments through AWS and Spinnaker than we are in the data center, which is just, again, just mind-blowing. You can see that as we're starting to move stuff out of the data center as well, then that rate is going to keep on going up and up. And my guess is we're probably, at the moment, we're doing about twice as many deployments for a small set of the applications, maybe I guess about 30%. So you can imagine that when the data center deployments drops down towards 0, then the Spinnaker deployments are going to go up through the roof just because we can deploy so much faster and so much more frequently and so much more easily. The other thing that's interesting about this slide is that we have a small number of outage instance for the data center, but we haven't yet, and this is not going to last forever, but we haven't had any production outages yet for AWS, which again is pretty cool given how long we've been doing it. So that's all fine. As I say, we've spent some time talking to developers very early on, and they didn't really believe us. And we were saying, hey, we've got this thing called Asgard, which is the precursor to Spinnaker, and we're saying, hey, this is going to be great. And they're going, that's really cool. No, it's just really, really great. And I said, yeah, sure. And then what happened was we actually got this stuff going. And by the way, the developers, lots of developers do get it, but I'm just using this for a point of illustration, really. So at the end of the day, what happened was, at some point, developers really got it, and they're going, this is a fantastic. And then they said, look, it takes a whole 8 minutes. Yeah, sure, we went down from a week or a month to get this thing deployed, but now it's still taking 8 minutes, get it down. And so that's good. So it's really great to have some people that are continuing to drive us to do better and better, because at the end of the day, we're really never, ever done. We've got a lot of work to do, a lot ahead of us. And the faster we go, it means that developers can push smaller and smaller deltas. And because they're pushing smaller and smaller deltas, it means they're going faster, which means we have to be able to build and deploy faster. And then we've got the landscape changes, right? So we've always got more tools and new technology that we've got to work out. So we think that's good. This is a fun slide for several reasons, I guess. But my favorite is that when I started putting this deck together, I wrote that line for open source Foremast. And then between me writing this slide, it actually happened. So kudos to the team for getting that done. And then we're just having to work faster and faster. So a couple of things on Foremast. Foremast is really cool. There's some URLs here. Go check it out. We've had a couple of conversations with a few companies that really like it. And when we met with a few companies a while back, they were saying, hey, this is really the missing piece of Spinnaker. But I haven't really explained what Foremast is. So the idea is you've got a pipeline you build in Spinnaker, which is created from a piece of JSON. And so that sets up all the different steps, like for building, for packaging, for doing deployments, for going back and tagging in Git, for getting approval for deployment to production if that's something you're interested in. And if your application is in a PCI or SOX environment, you're definitely interested in getting approval. And that's all okay. But up until now, developers have had to go in and configure all that by hand. And we decided pretty early on we didn't want developers to have to go and do all that overhead, because for them it's just more yak shaving, right? They just start off with writing code, and that's all they want to do. They want to write code, test it, make sure it works, and then write more code. And if they've got to spend half an hour figuring out how their custom pipeline should work in Spinnaker, that's a complete waste of time. So what we wanted to do was come up with some configuration you could put in your Git repo, and that basic configuration allows you to automatically get your Spinnaker pipeline built for you. And what I'm going to show you now is some fairly long-winded files, and it doesn't need to be anywhere near as big as this, but this is just kind of to illustrate what you can do. So there's two configuration files. The first one is pipeline. So here you can see that we've chosen EC2 instances rather than Lambda. We can set notifications, so when deployments happen, we know where to send messages. You can either do that through email or Slack, or there's probably some other ways as well. And I like the owner email thing simply because if you know that something, if you have a question as an administrator about a particular repo or application, if owner email is set, then now in DevOps, we know who to go to. In the old data center, it was always a complete pain in the neck to try and find out who owned a particular server. Now it gets really easy for us. And also in here, you can see we set environments. So we have stage and production here. Now, if we eventually what we want to get to the point is, or point of only deploying to production, never to stage, never to dev, and that brings some other challenges with it as well. And then so that defines the whole overall way it gets deployed. And then for each environment, whether it's dev or stage or prod or wherever else it is, you can set a bunch of other things as well. And again, I'm not going to go into a bunch of details about this. This is just to illustrate what you can do. But one of the things I will say is that over on the right-hand side there, you can see about halfway down, there's a section on regions. So now we make it really, really easy for you to say whether you want to deploy into either the West Coast or the East Coast of the US, into Europe, wherever you want. And so rather than, again, developers having to think hard about how they're going to deploy it to different regions, we make it super, super easy. So I don't know if you noticed, but I've been really good with attributions wherever I can throughout all this. And so this is something which seems really, really relevant, right? So we want to give developers both the freedom to do the things that they need to get done, but also they have responsibility. So if they write code and it's bad code and they haven't really written tests and they're not really sure what's going to happen when they deploy to production, but they do it anyway, and we get the whole duck and cover thing going on again, then there's a consequence, right? So they're going to get paged, and then they'll be woken up at 3 a.m. and they'll have to go and fix it. But that's good, right? Because then as developers, and I think probably most of us here are developers, but as developers, we should be proud of our code. We should be proud of our work, right? We want it to be good. We want it to be quality code. We want it to do its job. And I know that whenever I write code and it goes wrong, I want to hear as soon as possible when it's causing problems. So back to the attribution thing. So I think this is very relevant, but the only thing is that it actually comes from Austin Powers, which is, I don't know if any of you guys know this movie. I hear a few of you do. So this is intended as a joke when it was done, but for DevOps, it really is one of the big embodiments. So that's all I have. Thank you very much. We have some time. Does anyone have any questions? Down here and then you. Oh, do we have a mic?
Yes.
Yes, I'll repeat for you.
So I saw that you build it, you run it from Werner Vogels.
Yes.
And I saw the picture when there's only one guy and he will test, build, run, DevOps, everything. But then I heard you talking about the DevOps team, like a separate team. So how is it? Is it I build it and I'm checking it, or?
Oh, so yeah. So the question is about the developers being essentially DevOps, but then we've also got this DevOps team, and why would you have both?
So you're not building and running it. It's still another team that is doing all the DevOps, another team that is doing the development.
Oh, okay, no. So yeah, so for me the two are very, very different. The idea is that we want developers to be their own point of operations, right? So we want developers to be able to, at the push of a button, be able to deploy their code. to different environments. But there is a DevOps team, right? Because for us, it's the DevOps team that creates that button for them to push and provides all the tooling for them to be able to do make those changes safely. And when the DevOps team got started, really our big first job was to do all the yak shaving and eliminate as much yak shaving as possible. Does that make sense? Okay.
Before I ask my question, just one related to this one. Who gets the alert when something goes wrong?
In our setup, the question was who gets the alert when something goes wrong. So it depends, right? So if it's an application problem, then it's the development team that gets the page. And we want the development team, even if it's in the middle of the night. So development teams are having their own on-call schedule, and they're becoming increasingly responsive and understand the urgency of these things. I think it's still a little bit new for some of the teams, but we're getting there. But if there's a problem with Amazon Web Services, or if there's a problem with the DevOps tooling, then that's the DevOps team has to fix that, right? So if there's a problem with the Jenkins server or Spinnaker or Git, then DevOps gets those pages.
So on to my question, because that's related.
Okay.
How do you solve the issue of permissions? I mean that we also do this, the top developers get the alerts, they go into machines and fix it and all that stuff. They have root access, of course, to their applications, production servers. The guy who does the audit doesn't have it. What's your solution? Because we always keep hearing that we should limit the people who have permissions, that we should have a designated team who has the root access to the servers.
Okay.
It's a contradiction for us, and we want to keep the DevOps way.
Okay, so the question is around how do we ensure that only the right people have access to the servers when an outage occurs, so that we're making sure that nothing nefarious is happening in the background, right? And so we use AWS, and I'm sure it's probably true with Google Cloud as well, but there are several really, really important things you can do. The first thing is that Amazon has these ideas of security groups and IAM roles, and they allow you to restrict how all these different assets in AWS can talk to one another and how individuals can access servers. The other thing is that each of these environments is wrapped in access to via a hotbox, and the hop or bastion box restricts who can actually log into that domain of servers. So we're much more lenient in the non-financial systems, but the financial systems are really, really tightly restricted. Only a couple of people can get onto those. And for all the accesses are logged, and so we know who's getting on and making changes. And then, as I say, we tie down access to the assets like databases and email systems and so forth that are within those environments, and we also tie those down to individual applications. So only the responsible team can access those assets. Does that help?
Yeah, that's the way I want to go.
Okay. Any more questions? Hi.
Hi. So when you started, how far ahead did you plan, or did you just start with the first thing that came to your mind?
We kind of knew where we wanted to be, and we knew our sort of end goal, but we were very, very new to this. So we each of us, I think, had messed around a little bit with AWS, and we had some servers in AWS which were very data center oriented servers. So they're just EC2 instances, and auto-scaling groups were just created by hand. And it was kind of okay, but it wasn't really where we wanted to be. And we'd engaged a company by the name of Kenzan, and we said, hey guys, what should we do? And they spent a little while just kind of road mapping for us the kind of things that we should think about, not necessarily coming up with some hard and fast configurations or specific recommendations on tools, but they said, you should think about these things. And that was enough to get us started. Then in terms of specific tools, again, we thought about what the biggest bang for the buck was. What things could we do right now that would make a noticeable improvement and would gain credibility for the team? Okay, thanks. What else? Hi. I think we're sort of working. So the question was, do we have a roadmap for the future? So there was one slide a little bit further back, and so we've got VictorOps up and running, and that's great. But I want to get a much better idea of how well teams are responding. When do they have an outage, or how many outages do they have? How fast they respond? How fast can they repair? So that's one thing. Obviously, we want to close the data center. Canary deployments are really cool. So the idea is, or one of the ideas about getting away from the dev and stage environments and deploying straight to production is that we should be able to deploy just a very, very small amount of servers, taking a very small amount of traffic, and slowly ramp up the amount of traffic we move over to the new running servers, right? So that's going to be pretty huge. And then two other things. One, since we were pretty successful on the ground, our next thing we're working on is actually building a pipeline for the software that gets deployed to the plane. So we've got about 12 or 13,000 planes that have our software on between the two business units we have, and it's going to be really, really cool that if we can start building and deploying software to all those systems too, right? And then the other side is we have open source Foremast, but we have another tool called Gadget, and the Gadget goes and looks through AWS infrastructure and takes, it has a number of plugins, and different plugins can do different things to the AWS infrastructure. It's sort of just an ongoing management thing. Beyond that, I've got no idea, but but I know that probably in a month or two, we'll have a dozen more things to do. What else? I always try and ask what else rather than any more questions, because what else says, come on, ask me. Okay, all right, well, thank you very much for your time.